While everyone is joining, I would like to welcome you all to our next session with Shubham Shardul. And with that, I'll let him introduce his topic for today.
Yes, so hello everyone, I am Shubham Shardul. Today we'll walk through from problem to production, like how to combine retrieval, graph reasoning, and orchestration to build modular AI agents that are maintainable, explainable, and production ready. And I'll also share at the end a very simple demo code and show you the practical implementation of creating agent, which has become so easy nowadays, and also show you the MCP for the Neo4j. So let's get started here. Hello again, I am Shubham Shardul. I worked as a senior data analyst uh, in Accenture, and I am very enthusiastic about generative AI. I have been learning from the past 2 years, and I have also somewhat uh, talked about generative AI in sessions on Google Developer Groups events. Other than that, I work full time in Accenture currently. So let's go ahead with our presentation. So these are the topics that we will cover. We will cover the knowledge graph and why we use Neo4j. We will cover what is MCP and why we use it. And in the last, we will go through a small Neo4j MCP demo. These are the agenda for today. So let's get started. Yeah, I'll first want to know how many of you have heard of RAG. I think everyone have heard of RAG and everyone has been using RAG for a while now. So let's just go to the basics. What is RAG and how is it different from LLM? So what a RAG does is it just adds an external data source which acts as a context for the LLM and provides the LLM a certain point to provide some relevant output. But which external data source to use in RAG? We have worked with many of the relational databases, but have we heard of the knowledge graphs? I think some of you might have worked with knowledge graph also. So what is knowledge graph? If we search for knowledge graph on Google, we will come across these structures where we can see there are different nodes, uh, different edges here. So what actually is a knowledge graph? It is a representation of real world entities and their relationships. So these entities can be objects, events, while the relationships capture the context and the meaning of those connections. So as I said, there will be a node and its edge. These nodes are the entities and the edge will be the relationships. So what is a knowledge graph and why do we actually need to use it? So imagine walking into a library where instead of books being isolated, they are connected by relationships like written about the genre related to. So in that way, a knowledge graph converts a scattered data into a cohesive and connected system. Yeah. So before, whenever you searched on Google, you might have seen these kind of structures that appear and pop up in the right side. So before earlier, when we used to search anything, it was just a text search. But nowadays, what it does is it traverses the Google's own knowledge graph and gives out the nodes and the relationships that are connected to it. For example, if we search for Taj Mahal, earlier it just gave out these websites and links to the different websites that refer to that as a text. But nowadays we can see there is a different list of things that we can just find out just by searching for it. And that is possible due to Google's own knowledge graph. And have you heard of Neo4j before? I think Neo4j is the pioneer in the knowledge graph right now because of its simplicity, its flexibility, and its performance. And it is very developer friendly. It has its own Cypher query. So, have you ever wondered like why are we using knowledge graph and are not there any external other data sources like some relational databases and SQL and Postgres databases also which we can refer? Yes, we have been referring to those, and that is when we are using vector RAG. But why are we preferring graph RAG nowadays? Why are we preferring knowledge graph? Because the graph RAG offers a very low risk of hallucination. As you can see, there are other points where vector RAG is ahead, but the main point that we search for while implementing RAG in a production environment is the risk of hallucination has to be very low, and it has to provide its response based on the facts that you have provided in its external data source. So that's why we are preferring the knowledge graph approach. Now coming to the main part, agents. Have you heard of AI agents or generative AI agents before? I think you might have used it. Currently, ChatGPT has also launched its agent mode, which you might have used. So, have you worked with agents before? Have you built one? So if you might have worked with agents before, you have come across this agent as it is a combination of LLM. There is a design logic present, and there are tools that it can call. And finally, there is also a memory criteria, like you have to define the memory there. And its components, like I said, you have to define the prompts. There is a tool calling logic, and there is a session state for memory. So what agent does is it enables automation of complex workflows. It combines reasoning with external tool access. So it can act and generate queries, it can call tools, it can iterate again and again until it reaches the conclusion that the answer that it is providing is in context to the question. So any questions till now? No? Okay. Then we will go ahead with the problem that we are facing while building an agent and working with an agent. So in reality, whenever we work with agents in production environment, we just patch the connectors, we write glue code for each integration. So one change in the internal API that we might have been using, or one change in the vector store schema that will cause cascading failures. So there is no single place to discover what tools exist or to control who can call them. So this is the integration chaos that undermines agent reliability nowadays. So what can be the solution to this? The solution to this is that we can treat the tools as first-class citizens, as schema-driven services, and here comes MCP. So what the solution is, you might have heard of MCP before. Have you heard of MCP before? So MCP is basically a contract along with the registry for tool calling. MCP solves the integration chaos by turning connectors into discoverable, schema-driven services. It provides a single contract, name, input schema, and structured output that makes testing, swapping, governing tools straightforward. Agents no longer have to hardcode every connector. So let's drill into MCP and what it actually is, what it does, and why it matters for the engineering team to have them in the production environment. Okay, so MCP's Model Context Protocol, it is an open source standard for connecting AI applications to external systems. And just give me a second here. I think there is some issue with my screen. Yeah. So MCP, what it does is it brings several engineering benefits. Agent can programmatically discover what tools exist and their capabilities. The input schemas allow us to validate and sanitize inputs before execution. You can test a tool in a sandbox and swap to production without touching the agent code. So finally, MCP servers can enforce RBAC and log the calls for audits. That is essential for enterprise development in the production environment. Okay, so going ahead, we want to understand what MCP truly is. We are going to have a small deep dive now. So start with these primitives. Like every MCP tool publishes a manifest, a name, a version, and input output schemas. Agents ask the registry what tools are available and what they can expect. The transports vary: STDIO for local demo servers, HTTP or gRPC for remote servers. So crucially, the manifest enables the validation. The agent can refuse bad inputs before a tool ever runs. So now what we can do is we can just refuse the agent can just refuse the inputs before a tool ever runs. And by versioning the manifest, we can test a new tool implementation in a sandbox and then flip it into production gradually. So this is a basic MCP architecture that we have. So as you can see here, we have agent that we have used LangGraph agent here. We have the MCP server, that is the interface layer. We have the tool, the function API resource, and we have MCP registry here. So architecturally, MCP introduces a clean separation of the components. The agent is a thin client that discovers the available tools, validates the input, and invokes them. The MCP server hosts the tool implementation and executes it against backing services. The Neo4j in our demo, the Neo4j MCP in our demo, I'll be able to show you how it actually works. And around this core flow sits auth, observability, caching, and sandboxes. This decomposition buys us swappability and safety. The agent never needs to know the tool's internal runtime or credentials. Those are entirely encapsulated by the MCP server and its environment. So coming to the next topic, LangGraph. Now that the tools are standardized, we need an orchestration layer to manage all the agent logic and the memories. That is LangGraph. And as you have might known and might heard of LangGraph, many companies, I think most of the companies use LangGraph nowadays for orchestration and all the agent creation. But why LangGraph? So basically, LangGraph composes the LLM, the tools, the session state into a reproductive flow. And the pre-model hook that is present in the LangGraph core library, it controls what the model sees. The checkpointers persist conversation graph and the React nodes. And it is also very great for tool calling and reasonability. So together, what they make is they make the agent behave testable and debuggable. So putting all this together, what we need is a concrete MCP server, and for the demo, that MCP server for Neo4j Cypher. And I'll just give you an example of the Neo4j Cypher that we currently have. Yeah. So these are the three tools that we have currently in the Neo4j Cypher MCP. The first one is get Neo4j schema. Second one is read Neo4j Cypher, and the third one is write Neo4j Cypher. So our agent will be capable of generating Cypher queries on the fly to address user questions about any of the questions related to its schema. We don't need to modify the data. We only use get Neo4j schema and read Neo4j Cypher for now, as it is also recommended for the production environment to disable the writing of the Neo4j ciphers. Okay, so now what this MCP package does is it wraps the Neo4j cipher into discoverable schema-driven tools. For safety, the demo that I'll show that will only use the get Neo4j schema and read Neo4j cipher. We will avoid writing any changes, and we bootstrap the MCP server with UVX so that we don't need to clone the server code. Yeah. And once the stdio client connects, we call load MCP tools function and filter to the tools that we want. Some of the important thing that we might want to note here is uh, never use the credentials directly in your code and don't embed them directly in the code. Use environment variables and always parameterize the generated cipher to avoid injection. In this demo, you will see the agent first request the schema before it generates ad hoc cipher. So this is the small and important step that dramatically reduces the semantic errors when the model writes the queries. Okay, so let's just go ahead to the small code that I have. I'll uh, walk through it and I will show how easy it is nowadays to create a React agent using LangGraph and how easy it is to just connect the MCP server to it and get it running. Just give me a second. I'll uh, open that demo. Are you able to see my screen? Yeah, I can see it is visible now. So just 1 second. I'll just close out these libraries. Yeah, so this is a very simple code on how to create a small agent and connect the Neo4j cipher, and we will see how much it will impact how we use Neo4j. So it showcases a powerful AI agent that provides movie recommendations using Neo4j. And as for the LLM, I have used Google's Gemini. This agent combines the natural language processing with the graph database queries that delivers personalized movie suggestions. So at first, I have just imported all these things from LangGraph, and these are essential imports for async operation and environment variable. As you can see, we use .env to load the environment variables. Yeah, and why is it not moving? Yeah. This is the main function that we have defined here, find movie recommendations. This function is the core recommendation engine that takes a movie title and optional parameters for rating threshold and result limit. It uses a cipher query to find similar movies based on the user ratings. What it returns is it returns recommendations based on what the users who like the target movie also enjoyed. So it includes metadata like IMDb ratings and the number of supporting users. And here is our next function, fine. And this is the base model that we have defined for the above function. And after that, we have defined this tool. So this is the local tool that we have, this movie recommendation, find movie recommendation tool. This is the local tool that we have with us. That will give us recommended movies based on the movie that we ask it to. Okay, so this is the tool definition. After that, we have just introduced the MCP cipher here, MCP Neo4j cipher here. So as you can see, we just have to put the command UVX here, and we have to give the environment variables like Neo4j URI, username, password, and the database we wanted to connect to. Yeah. And this enables it also handles the authentication and the database selection, as well as it enables the secure communication with the database. So after that, we have given a system configuration and a system prompt. that you are a Neo4j expert and you have to write Cypher queries. After that, this is one of the main parts, the pre-model hook. So as you can see, what this pre-model hook does is it manages the conversation context. It implements token limiting that is there to mainly prevent the context overflow. It ensures there is efficient use of the model's context window. After that, we have print a stream. This print a stream function is basically to print all the intermediate querying that is there that the agent is running through. All that will be streamed live on the terminal. After that, we have our main function where we load the MCP tools and where we have these two tools, get Neo4j schema and read Neo4j cipher with us. So these are the tools that we have based on the Neo4j cipher MCP. Other than that, we have this local tool also present with us, which we have defined in the starting. So here is a very basic LLM that I have used. I was testing out with various LLMs and uh, it and as a result, I was able to find out that even with most basic LLMs, we are able to run this perfectly. After that, we are creating a basic agent. As you can see, and as I have said earlier, creating an agent nowadays using the LangGraph is very easy. We just have to give the LLM, we have to give the list of the tools that are allowed there, and we have to also give definitions about our context window and the memory that we are going to use. And lastly, there is the system prompt that we defined earlier. So just running this will trigger this. Let me run this. I think it has been running. Let me close this one and start again. Yeah. So as you can see, it is very start and it has start. It is very fast and it has started running. So we can ask simple questions like, give me movies with Tom Cruise in it. And what it does is, as we can see here, it uses this pre-model hook to maintain the context window. And after that, it uses the get neo4j schema. So this is the schema that we have in neo4j. After that, it does another tool call that is read neo4j cipher. So what it does is here, it generates a cipher query based on the question that we provide and the context. What is the context here? The context is the schema that we have derived. So based on the schema and the human message, it forms a query. So here is the query, as you can see. It is perfect. After that, it will just make the tool call, iterate again and again until it is satisfied with the answer. So it has come up with these movies of Tom Cruise with their release dates. So as you can see, there are many movies here. I can, let's now use the local tool call. Let's see if the local tool calling also works. So what I will say is I like Mission Impossible. Recommend me movies based on that. Okay. So what it does now is it will segregate the movie title that we have provided in the human message, and it will see that we are asking for a recommendation of on the movies. So what this agent will do is it will choose the tool that we have defined locally to recommend the movies. Yeah, find movie recommendation, and then it has again for any generating of the cipher query, you have to get the neo4j schema for it to be correct. So it has derived the neo4j schema. Meanwhile, it will also generate the query. So here is the query. One second, this is the previous one. Yeah. So it has generated the query and it has hit the database and come up with these. So let's see. What it has given us is Forrest Gump, Pulp Fiction, and these are based on the database that we have. It We can see here 40 people who loved Mission Impossible also rated this as an average of 4.5 stars out of 5. So we can see we have these many answers here, and the tool calling is working perfectly fine. It is using two of the MCP Neo4j cipher tools, that is read Neo4j cipher as well as the uh, get schema one, to get the schema and write a query and then derive the answers for us. So that was it with the demo. Any questions till now? If not, then I'll stop sharing this screen and then I'll go to one other thing, as we have only 2 minutes left with us. Yeah. Mm, yes, here it is. Yeah. So what is the most recent advancements in the Neo4j MCP? So the earlier that we were just viewing right now in the code, in the demo code that I was showing, was a contribution to the Neo4j Cypher MCP. But this is the official MCP server announced by Neo4j just about a month ago, and this is it in its beta version right now. So let me just load it and give you the hint. It is basically very similar to the earlier one that I was showing. Just 1 second, I'll share my screen again. Yes, here it is. Yeah, as you can see, this is the Neo4j MCP in its beta version, and it is very simple to just download this archive from here and get started with it. You can just install it and use this instead of what I have been using in the demo code. You can just use this to get started with it, and it also has these tools. As we can see, the get schema tool, it has read cipher, write cipher, and it also has this one extra tool, that is list the GDS or graph data science procedures that we have. So that's it from me. If you have any questions, I think in the chat I can see graph database is pre-built. Yeah, once again, graph database is pre-built based on IMDb database. Yeah, this is an example database that is provided by Neo4j. You can search for it, movie recommendation database, and you can see and explore it. If you have any other question, I have not seen the allowed tools concept before. That is a good idea. Yeah, it is. We can develop our local tools as well as we have all the tools from the Neo4j. So thank you everyone. I think it was fun presenting this.